So let's talk about volume today. So first off, what is volume? So volume is something we calculate with three-dimensional shapes. So if you remember for area, what we're doing with areas, we're essentially saying how many little squares of a certain side length can we fit inside a 2D shape? Well, with volume, we're doing the same idea, but instead of squares, because we're dealing with 3D, we're looking at cubes. So you imagine this solid and you're thinking, okay, how many little cubes of, 1 foot by 1 foot by 1 foot as length, width, and depth can I fit into this shape? And that's the idea of volume, is how much space is inside a 3D shape. And because it's in 3D, we have a height, we have a base, and now we have this additional depth. We have 3 dimensions. We're going to be looking at cubic units. Okay, so we have formulas we can use to talk about finding volume. And what's neat about volume is, just like with surface area, prisms and cylinders are essentially the same type of shape, just one has straight edges and the other has curved edges. But really the formula, it's the same basic formula. And then similarly for pyramids and cones, which we'll get to later, it's basically the same basic formula, just the difference is the shape of the base. So let's talk about the formula. The formula for prisms and cylinders are the same. Volume equals the area of the base times the height of the prism or the cylinder. So capital B stands for the area of the base, and then H is the height of the solid. Not to be confused by the height of, let's say, a triangle, so of a 2D shape. Okay, so if you remember when we talked about a solid, the height is the distance between the bases. So that's the height here of this prism, and this is the height of your cylinder, because remember the base of the cylinder are these 2 circles. The base of your prism in this shape would be these 2, what is this, a pentagon? Yes. So that's the base. So the height of the solid is always the distance between the 2 bases. And then with your prism, right, the base shape will change. So the base could be a pyramid, a pentagon like this. A base could be a triangle. Your base could be a 100-sided shape. It depends on the prism. However, for the cylinder, the base is always a circle, which is why you will also see the volume formula for a cylinder be written as pi r squared h. Now, is that really different from capital B times h? No, because capital B, the area of the base here, is just pi r squared, so we're just substituting that in. So it's kind of up to you if you want to memorize 2 formulas or 1. It's up to you. It's the same thing. That's what I'm basically trying to say. Okay, because this right here, this pi r squared, is capital B for all circles. All right. Okay, let's look at some examples. So find the volume of each solid, leave your answer in simplest radical form or in terms of pi. So when you see that, you want to recognize, okay, no rounding. All right. So we have pi when we're dealing with cylinders and cones, when we have circles, right? And we're dealing with simplest radical form or exact values, right, exact numbers when we're dealing with prisms. So part A, we want to find the volume. So make sure you see that. Of a cylinder with base area 121 pi square centimeters and a height equal to twice the radius. Now, if it helps you to draw the picture, you can definitely draw the picture to help you visualize everything, but you don't necessarily have to, because this all just boils down to knowing the different components of your formula. But let's go ahead and visualize this. We're going to have a cylinder, so we have a circle and another circle as my 2 bases. We know the base area, which is capital B, is 121 pi square centimeters, and the height, h, between the 2 circles is 2 times the radius. So hopefully you see here, what do we have to solve for first? Well, what is this radius, right? Because I can't find the numerical answer without knowing the radius. So let's pause and think, well, how do I find the radius? Where is radius when we talk about this entire problem? Well, hopefully you remember, wait a minute, this capital B, this base area, this is pi times radius squared, because we're looking at area of a circle. And if 121 pi equals pi r squared, we can totally find the measurement for r, right? Because I can divide both sides by pi, since pi is a number, and then I can square root 121. We want the positive value because radius is a measurement, so radius is 11. So then 2 times 11 is 22. And now we can go to whichever format of your volume formula you want to use, and I prefer just to memorize one, so I'm going to do capital B times H. Remember, always write down the formula before you plug in your values. We were told that capital B is 121 pi, and then now I know height is 22. So I can simply just do 22 times 121 to get a volume in terms of pi of 2,662 pi. Remember, volume's in cubic units because we're thinking how many cubes fit in. So that's cubic centimeters. All right. If we look at part B, we want to find the volume of this right regular hexagonal prism. So regular hexagon, that should clue you in, that's our capital B. So we want to go back and think, well, wait, how do I find the form area of a regular hexagon again? 1/2 apothem times perimeter, right? And we're looking for volume. So at the end of the day, we want to do capital B times H. So why don't you guys take a moment and try to find capital B for me. So going back to what we talked about earlier, how do you find the area of a regular hexagon given all we know here is the side length of 9? So, right, just giving you a quick picture, we know this is 9 feet. We want to find the area of this. So go ahead and try and calculate that out for me. All right, guys, so hopefully you see we have a 30, 60, 90 triangle, and I know when we talked about area before, we said, oh, you could also use tangent, but remember the direction said simplest radical form, so if you're doing tangent 30, you can, but then you still have to convert that into its radical. So I was thinking, why bother doing the extra work if I can just do the 30, 60, 90 triangle? So remember, your long leg, which is the apothem, is the short leg times the square root of 3. The short leg is 1/2 the hypotenuse, right? But we don't have the hypotenuse, but we do know if we cut that triangle that I'm highlighting right here, if we cut that in half, we cut that 9 in half, which is how I got that 4.5 as my short leg. So 4.5 square root 3 is my apothem. Perimeter is just 9 times 6 because we have 6 sides that are 9 feet each. And then we get a base area of 121.5 times square root 3. Okay? So that was probably the toughest part, and that's just review. Right? With the formula for volume, it's actually really straightforward. Once we have our pieces, we're just multiplying two numbers. So the height here is just the height between the two hexagons, which is 12 feet. So once I did all that tough work to get 121.5 square root 3, it's pretty easy from there. We're just doing capital B times H, which is 121.5 times the square root of 3, times what was given to us, which is 12. Remember, we don't distribute or anything because we don't have a plus sign between 121.5 and root 3. And we only want to multiply the numbers that are actually that we group together, right? So 12 is not inside the square root, so we leave that square root 3 alone. And our final answer is just going to be whatever 121.5 times 12 is, and then tack on that square root 3 at the end. So we'll get 1,458 square root 3. Once again, don't forget your units, cubic feet. So once you know your formula, the formula, I think it's pretty basic, right? It's just area of the base times height. What's tricky can be finding the area of the base depending on your shape, or perhaps working backwards and knowing which formula you're using for the area of the base. Because of course I can say, hey, given volume is 1,458 square root 3 cubic feet, and the length of the side of your hexagon is 9, go back and find the height of your prism, and we should be able to work backwards that way as well. Okay, so those are prisms and cylinders. Then next up we're going to talk about pyramids and cones, and like I said before, pyramids and cones pretty much the same shape. The only difference is the type of base you have. So you can memorize one formula or you can memorize two. It's up to you, because a lot of our textbooks, and ours included, will have the formula specific for a cone, but you'll realize it's just with the area of the base put in. Okay, so what is the formula, which is probably what you're all dying to know, right? The formula of a pyramid, for volume of a pyramid and a cone, is actually really cool. If you had a little cup in front of you that has, let's say they're cones, and you have a cone with like a radius of 2. If we have a corresponding cylinder with the same height and also radius of 2, you'll realize the cone is exactly 1/3 the volume of the cylinder. So this formula is just what we had before, but times 1/3. So the volume is 1/3 the area of the base times the height, because your corresponding cylinder or prism will be 3 times the size in terms of the space inside of the prism of the pyramid or cone. So anyway, I think that connection is kind of cool. But what you need to know is the volume is 1/3 area of the base times height, where again capital B is area of the base, and H is the height of the solid. So just like when you were doing surface area back in middle school, when we talked about surface area for pyramids and cones, we were looking at the slant height. However, for volume, we're not going down the surface, right? So what we want is we want this altitude, which is also what we call the height. So you'll see it's perpendicular right to the center of your base. So this is height, H. We don't really care about the non-regular pyramid. I have that on there to show you guys they exist, but don't worry about it. We're only going to be looking at regular pyramids and cones. So again, this axis that's labeled is what we call the height. So you can see how it goes from the vertex all the way down to the center of the base. We don't actually care about slant height for volume. Slant height can be useful to help us find the height, and we'll see that in one of our examples in a moment, but we don't actually want to use it. Remember, slant height is this cursive L. It's not part of our formula. Slant height goes on the surface. It's for surface area. Regular height goes down the center, which is the space inside. It goes inside. We want that for volume. Okay, so 2 examples and we'll wrap up here. We want to, oh, before I forget, the second formula here, if you want to know it just for the cone, remember for your pyramid, the bases change. The base shapes differ, so you could have a hexagon, you can have a square, you can have a 12-sided dodecagon, right? But for the cone, the base is always a circle. So you can always write this formula as volume equals 1/3 pi r squared h, and you can see all that is putting in pi r squared for b. So that's why I said it doesn't matter which one you memorize, because as long as you know area of the circle is pi r squared, you'll be able to plug it in yourself. Okay? All right, moving on to examples. Find the volume of each solid. So once again, we know our goal. We want the volume. Leave our answer in simplest radical form or in terms of pi, depending on the problem. So we don't want to round anything based. Okay, so part A, we are looking at a rectangular pyramid. So really, really important for you guys to know what shape we're dealing with, because it's really easy to mistake pyramid with a prism. So please double check, triple check, do I have the right formula? Because we don't want to have the wrong formula because we thought it was a different shape. So I'm looking for a pyramid with a rectangular base, length 11, width 18, height 23. So if it helps, feel free to draw the picture, and I am no expert at drawing pyramids, so you guys might be better than me at this. But feel free to draw it in. So we want to make sure it's a pyramid, not a prism, because I make that mistake sometimes too. If I go too fast, I'm like, okay, let's draw a prism, but no, wait, it's a pyramid. So the length and the width are parts of the base. So this rectangle has a length of 11, width of 18. It doesn't matter if you flip those two around. And then remember the height. The height goes from the vertex straight down to the center of our base. So that's 23. It's not slant height, it's plain old height. And then we can say, okay, we're looking for volume. Volume is 1/3 area of the base times height, because I'm dealing with the pyramid. And then we know, hey, area of the base is just base times height. Or if you don't want to have so many heights, we can call this length times width. So that's 11 times 18, which is just 198. We know height again is 23. So volume is 1/3 of 198 times 23. So volume is going to be 1,518. Don't forget units, cubic meters. All right, next one. So now we're dealing with a cone. So we can see that from the image. So right off the bat, we want to think, okay, I'm looking for volume. What's my volume formula for a cone? Once again, you can either remember it specifically for the cone or start off with the same formula as your pyramid because it's the same thing. And we know capital B is just pi r squared, right? And we'll look and we'll notice from the diagram that, hey, radius is 16, so cool. We can find the area of the base, so that's 16 squared. So area of the base is 256 pi. I'm leaving it in terms of pi because I want that in my final answer. And now the question is, okay, h, well, that's 34, right? Is it? It's not, because remember 34 is along the surface. So this is slant height. So the height that we actually want is going straight down the center. So how do we find that? Okay, so we're going to use our Pythagorean theorem. So remember, it's always important to not think of every concept as something that's not standing alone, right? That doesn't get impacted by anything else that we've learned. We can always dig deep into our pockets, into our memory, and think, well, what else applies here? What other shapes have we worked with? What other concepts have we learned that can help us find missing information? So if we know that this leg is 16, the hypotenuse is 34, and we're missing the height, which is another leg, we can simply do h squared plus 16 squared equals 34 squared and solve with that handy Pythagorean theorem. So we'll find out that h squared equals 900, square root both sides, and h is equal to 30. Not negative 30 because it's a length. And of course, remember, it's okay for this to be a uglier value. Like this could be 30 square root 3. It doesn't matter, right? We want to find that exact value. And once we know h, just put it back here into volume. So volume is going to be 256 pi times 30. And you don't have to find capital B on its own. I was just showing you we can find that right away. You can do it all in one step if you'd like. But let's go ahead and finish this off. Oops, and I forgot my 1/3. That's important. So we're going to do 1/3 of 30 times 256 pi. So that will be 10 times 256, or 2,560 pi. And don't forget your units, cubic centimeters. Okay, so those are just two examples showing you how we can deal with our volume formulas. But like I was saying earlier, we can also work backwards. What if I told you volume is 2,560 pi and the radius is 16? How do you go backwards and find height? You should be able to manipulate your volume formulas in any way, shape, or form. I could also say, hey, given volume is 2,560 pi and the height is 30, find the surface area. And then you should be able to figure out, oh wait, that missing link, right, is the radius because I'm given the slant height from the diagram and I need to find the radius or whatever. So we should be able to kind of fluidly find missing information to help us solve the problem. Okay, so that wraps up volume. Please let me know if you have any questions.